Okay, so let's do this question. So a company hosts its web app in the AWS cloud. Company configures Elastic Load Balancers to use certificates that are imported into AWS Certificate Manager. The company's security team must be notified 30 days before expiration of each certificate. What should a solutions architect recommend to meet this requirement? For starters, I'm asking a question. I'm not even sure right now. When you import certificates on AWS Certificate Manager, let me see. Obviously, you can't renew them. Obviously, you're not able to renew. During renewal, you're not able to renew them because they've been imported from somewhere else. So let's see what you can do. Okay, so add a rule in ACM to publish a custom message to simple notification service every day, beginning 30 days before a certificate will expire. Okay, that doesn't seem very clear. Let's see B. Create an AWS config rule. That's already maybe a point. I mean, create a rule and let AWS config have, maintain that configuration. Monitor for that configuration to make sure it actually consistent. It's persistent. Okay, that checks for certificates that will expire within 30 days. Configure Amazon Event Bridge / CloudWatch events to invoke a custom alert by way of SNS when AWS configs a report of non-compliant. Now that makes a lot of sense. Okay, created that will expire in 30 days. Configure CloudWatch events to invoke a custom alert by way of SNS when AWS config reports a non-compliant resource. Okay, let's see. Use AWS Trusted Advisor check. You probably can't do that. Trusted Advisor check. Trusted Advisor usually we use it for best practices. I'm not sure if it can actually work in this case. Create that is based on Trusted Advisor metrics. Not really. Create an Amazon Event Bridge to detect any certificates that will expire within 30 days. Configure the rule to invoke Lambda function. Configure the rule to invoke a Lambda function, and then configure the Lambda function to send custom alert by way of simple notification service. Okay, I feel like D is doing way too much. To detect any certificates that will expire in 30 days. Then configure the rule to invoke. So why can't the event bridge just invoke an SNS topic? Why does it have to go through a Lambda function? I feel like D is just a confusion. I'll go with B. Create an Amazon AWS config that check for certificates. Let's see. They're saying the correct answer is D. They're saying the correct answer is D, right? Okay, so they're saying correct answer is D. Then we also have create an AWS config rule that checks for certificates. Now that's weird. Event bridge to detect any certificates that will expire. Create an Amazon rule. CloudWatch events rule to detect any certificates that will expire. Yeah, I'll go with B definitely. I'll go with B. See, next question is: a company's dynamic website is hosted using on-premises servers in the United States. Company is launching its product in Europe and it wants to optimize site loading times for new European users. The site backend must remain in the United States. The product is being launched in a few days and immediate solution is needed. What should we recommend? Okay, before we even go to that, it's a dynamic website being hosted on premises servers in the United States. The company is launching its product in Europe and it wants to optimize site loading. Now, I guess the site's backend must remain in the United States because it might be a compliant issue. So the product is being launched in a few days and an immediate effects solution is needed. Few days. So what should the solutions architect recommend? In this case, number one, backend has to remain here. So backend seems like we don't need. Backend has to remain in the United States. I feel like the best solution here would be let's see. Sounds like it's a dynamic website. So okay, static assets. Okay, CloudFront might have been there, but I'm not sure. So let's just read the answers. Launch an Amazon EC2 instance in US East 1 and migrate the site to it. Okay, migrate the site to it. Weird. Move the website to Amazon S3. Use cross-region replication. Amazon S3 can only be used for static websites, so dynamic website that already takes it out. Use Amazon CloudFront with a custom origin pointing to the on-premise servers. Okay, using on-premise servers in the United States. Then use an Amazon Route 53 geoproximity routing policy pointing to on-prem servers. Okay, geoproximity routing policy pointing to on-prem servers. This one, okay, Amazon Route 53, that is supposed to be something about increasing loading times. Route 53, no. I'm going to go with CloudFront with a custom origin. So when we do custom origin, we're going to input the custom origin as Europe, a custom origin, CloudFront. So you don't have to pay much. By default, CloudFront usually does worldwide, but if you do custom origin for Amazon CloudFront with a custom origin pointing to on-premise servers, I'm not even sure. Yeah, I guess C is the answer. I was quite a bad sharp. Okay, let's see question 84. A company wants to reduce the cost of its existing 3-tier web architecture. The web application and database servers are running on Amazon EC2 instances. So it wants to reduce the cost of 3-tier web architecture. Okay, good. Amazon EC2 instances, the Amazon EC2, the web application and database servers are running on EC2 instances for development, test, and production. The EC2 instances average 30% CPU utilization during peak hours and 10% CPU utilization during non-peak hours. That sounds about like they're wasting resources. The production EC2 instances run 24 hours a day. The development and test EC2 instances run for at least 8 hours each day. Okay, so production instances run 24 hours a day. I can already see where this is going. The company plans to implement automation to stop the development and test instances when they are not in use. Which EC2 instance purchasing option will meet the company's requirement most cost effectively? Let's see which one the company plans to implement. So already we know the production is always running 24 hours a day. Yeah, so with 24 hours a day, we are not sure, are they in it for the long term? So with 24 hours a day, you can go for reserved instances, and you can say usually the cheapest reserved instances would be full upfront reserved instances. Full upfront reserved instances are usually the cheapest one, and you can do it in 1 year. You can pick up 1 or 3 year contract. Okay, so I'm definitely going to use that. And then, so the development and test instances run for at least 8 hours each day. The company plans to implement automation. So, okay, so this is, we already give it a reserved instance. And then now for instances, 8 hours each day. Development, Spot. We can't run this on Spot because we haven't been told if that kind of workload is actually is fault tolerant. So let's see, use Spot instances for production EC2 instances. That is already wrong. We can't even look at that twice. Use reserved instances for production EC2. Use on-demand instances for development and test instances. It makes sense. So if it runs 8 hours, then it can stay idle for the time that is not running. Now use Spot blocks for the production EC2 instances. That doesn't make any sense. Use on-demand for production instances. Then use Spot blocks for the development and test instances. So 10 hours. So one of the things is that the average, we've been given average CPU utilization, so we know what to expect. So in this case, we just pretty much so production the development ran for at least 8 hours a day. The company plans to implement automation to stop the development and test EC2 instances when they are not in use. Which purchasing solution? Yep, cost effective. I'm simply going to go with the reserved for EC2 production, on demand for that test. Let's see. B is most community voted B, so I would concur with them. A company has a production web application in which users upload documents through a web interface or a mobile app. According to a new regulatory requirement, new documents cannot be modified or deleted after they are stored. What should the solutions architect do to meet the requirement? According to new regulatory requirement, new documents cannot be deleted or modified after they are stored. So that one I already cannot be deleted. So that would say you'd probably place an object lock, legal hold. I'm not sure. Is it legal hold? Let's see. Store the uploaded documents in Amazon S3 bucket with S3 versioning and object lock enabled. Okay, so S3 versioning and object lock enabled sounds about right, but let's check. Then let's check the others. Object lock is enabled. I'm not sure, they didn't specifically mention what kind of object lock. Store the deployed documents in an Amazon S3 bucket. Then configure an S3 lifecycle policy to archive the documents periodically. Okay. Store the deployed documents in S3 bucket, configure an S3 lifecycle to archive the document. That doesn't do anything for deleting the documents. Store the deployed documents in S3 bucket with S3 versioning enabled. Configure an ACL to restrict all access to read only. That doesn't do anything for deleting. Store the deployed documents on EFS. Access the data by mounting the volume in a read-only mode. Yep. So deleted after they're stored. That S3 object lock. So usually versioning helps because when you have versioning enabled, when you try to delete something, it's simply marked as a delete marker. Yeah. So if you delete it's so weird when you delete a delete marker, that is how you restore a particular object. So A should be the answer in that case. I concur with the community 100%. A company has several web servers that need to frequently access a common Amazon RDS MySQL multi-AZ DB instance. The company wants a secure method for the web server to connect to the database while meeting a security requirement to rotate user credentials frequently. Which solution meets this requirement? So a company has several web servers that need to frequently access a common RDS MySQL multi-AZ DB instance. A lot of nothing. The company wants a secure method for web servers to connect to the database while meeting security requirements to rotate user credentials. Now, one thing I know about rotating user credential, if it's a managed service that you don't have to manage, AWS Secrets Manager usually has that ability to rotate credentials, and that is probably one of the biggest difference between Secrets Manager and AWS Parameter Store, right? So which solution meets this requirement? Number one, store database user credential in Secrets Manager. We are good. Grant necessary IAM permissions to allow the web servers to access AWS Secrets Manager. That's about goes. Sounds okay for me. The company wants a secure method for web servers to connect to the database. Okay. Web servers to connect to the database. Okay. B. Store database user credential in Systems Manager Ops Center. Grant the necessary IAM permission to Ops Center. Yeah, it doesn't make sense to me. Store database user credential in a secure Amazon S3 bucket. Doesn't make any sense. Store database credentials in file encrypted with AWS Key Management Service on the web file server. I'm going to go with A. Secrets Manager already takes care of rotation of everything, so that about goes to be the answer. Question 87. Company hosts an application on AWS Lambda functions that are invoked by API gateway. Lambda functions save customer data to an Amazon or MySQL database. Whenever the company upgrades the database, the Lambda functions fail to establish database connection until the upgrade is complete. The result is that customer data is not recorded for some of the events. A solutions architect needs to design a solution that stores customer data that is created during database upgrades. Which solution is this? Okay, this doesn't make any sense, but basically sounds like during the sounds like during the upgrade, what we need to do is to introduce a new service so that during the upgrade, all the services can be queued, and then when upgrade is done, the function can pull those particular results. So this sounds like we're just going to introduce SQS. Let's see. Provision an RDS proxy to sit between the Lambda function and the database. Configure the Lambda functions to connect to the RDS proxy. Doesn't sound okay. Increase the runtime for the Lambda functions to maximum. Create a retry mechanism in the code that stores the customer data in the database. Persist the customer data to Lambda local storage. Configure new Lambda functions to scan the okay. This D sounds store the customer data in SQS. Fast in fast out queue. Create a new Lambda function that pulls the queue and stores the customer data. D sounds about like my most correct answer. Yeah, because if during upgrades, the Lambda functions cannot work, then you simply queue it in an SQS, and then when it's fully upgraded, this is a fast in, fast out, then it can now pull them and continue the work. Sounds about right. So I see most people say A. What is A? Is provision an RDS proxy to sit between the Lambda function and the database. Okay, Lambda function and the database. Provision an RDS proxy to sit between the Lambda function and the database. And a lot of discussions here. Okay, listen. You're going to tell your boss that the customer is going to occasionally lose, as if that's just acceptable. Ideas proxy minimizes application disruption from outages affecting the ability of a database by automatically connecting to a new database instance while preserving application connections. Okay, that doesn't make any sense. Doesn't make any sense. Doesn't make any sense. This guy was like, you're going to tell your boss that customer is going to occasionally lose only 33 of their data as, and if that's just acceptable. It says reduces fail over time by up to 66%. Occasion more than one instance. Yeah, okay, yeah, doesn't make any sense. That's about sounds like this one. Let's see. Survey. Survey company has gathered data for several years from the areas in the United States. The company hosts the data in Amazon S3 bucket that is 3 TB in size and growing. The company has started to share the data with a European marketing firm that has S3 bucket. The company wants to make sure that its data transfer costs remain as low as possible. Which solution meets this requirement? So we want to share 3 TB. 3 TB we can use Amazon Snowcone. Snowcone does up to like 5 terabytes, I believe. Snowcone sounds like something we would do. But if it's not here, we'll see. Configure requester pay feature on the Amazon company's S3 bucket. Amazon has gathered for several years. The company hosts data in the S3 bucket that is 3 TB in size and growing. Okay. The company has decided to share the data with European marketing firms. The company wants to ensure, okay, as low as possible. So let's see. So configure S3 cross-region replication from the company's S3 bucket to one of the marketing firms. Configure cross-account access for the marketing firm so that the marketing firm has the access to the company's S3 bucket. Configure the company's S3 bucket to use intelligent tiering. No. So D is wrong. I feel like cross-account access for marketing firm so that this sounds like you are only paying for requests. Cross-region replication sounds more expensive, so I'm going to go with C. Okay, so C. Which solution meets this requirement? The company wants to ensure, as low as possible. So this says most voted and B is most voted. Well, I guess I did fuck up there. Cross-account access for the marketing firm so that the marketing firm asks Amazon S3 bucket. Configure the requester pays feature on the company's S3 bucket. I'm not even sure what that is at this point. I will revise that. So this is what's happening. Configure cross-region application from the company's S3 bucket to one of the marketing firm S3 bucket. How cheap is that? Okay, I guess C wasn't the answer that I expected. Let's let it. I will check out that later. Okay, let's see. A company uses Amazon S3 to store its confidential audit document. The S3 bucket uses policy to restrict access to auditing team. I am user credential according to the principle of least privilege. Company managers are worried about accidental deletion of documents in the S3 bucket and want a more secure solution. What should solutions architect do? So when you see accidental deletion, one thing we're supposed to do, you can enable versioning, and then number 2, you can do multi-factor authentication deletion. Yeah. So enable versioning and multi-factor delete features on S3 bucket. That is true. Enable multi-factor authentication on the IAM user credential. That is for IAM. That is not specifically for S3 bucket. Add S3 lifecycle policy to audit the team's IAM account to deny S3 delete during audit dates. Yeah, that doesn't look like a best solution. To deny during audit days. No. Use AWS key management service to nope. That sounds like A. Multi-factor authentication, MFA delete, and S3 versioning. And then a company is using a SQL database to store movie data that is publicly accessible. Database runs on RDS single AZDB instance. Okay, so a company using SQL database to store movie data that is publicly accessible. Database runs on Amazon RDS single AZDB instance. So obviously it's not very highly available. Script runs queries at random intervals each day to record the number of new movies that have been added to the DB. The script must report a final total during business hours. Company's dev team notices that database performance is inadequate for development tasks when the script is running. A solutions architect must recommend a solution to resolve this issue. Which solution will meet the requirement with least underline list operational head? overhead. So we have Amazon RDS single AZDB. So basically what we can do is we can modify DB instance to be multi-AZ deployment. Now that makes it highly available, but in this case we want performance. So we can create a read replica of the database, configure the script to query only the read replica. Sorry, that makes sense. Instruct the development team to manage. Nope. B sounds like the answer in this particular case.